Na karibu katika lecture nyingine, na hii ni lecture namba 10. Katika lecture iliyopita tulimalizia na DC 2 wire system with one conductor FD. Okay, kwa hiyo kwa sasa tunaendelea na DC, DC 2 wire system with midpoint FD. Okay, more simple, tutakuwa tuna 2 DC generators. Okay, this is one generator. Okay, this is the midpoint being FD. Okay, and the voltage between any conductor and the ground is Vm, kama tulivyoona katika basis of our comparison. Okay, Vm. Okay, now the voltage between the two outers will be twice of Vm. Okay, okay, kwa hiyo if the load of P watts is connected, current I starts to flow, ndio current I will flow and will be back to through another out, or the current I will be given by power times twice of Vm. Okay, power loss itakuwa ni I squared times R, ambayo ni I square P over twice Vm squared times R. R inakuwa given by resistivity load times length over area, kama tulivyoona mwanzo. Okay, kwa hiyo power loss W itakuwa sasa na kusema P squared times resistivity load times L over 4 Vm times area. Now ukimake A the subject, kwa equation napata P squared resistivity load times length over 4 Vm times W. Okay, unajua kabisa volume of conductor material is given by area times length. Okay, kwa vile ni two conductors, we add 2 here. Okay, multiply by 2, kwa tunasema volume of conductor material itakuwa ni twice times area. Area is P squared resistivity load times length over 4 Vm times W bracket times L. Okay, tutakuja kupata V equals to tunapata 2 chini, tunapata P square resistivity load L square over twice Vm times W. Sawa. Sorry, kuna mistake kidogo. Power loss is given by kwa vile two conductor is 2. Okay, 2 will be, we have 2 here, we shall have 2 here, multiply by 2, and here we have 2. Okay, and here will be 2. Okay, hapo itakuwa ni 2. Okay, kwa 2 times 2 will be 2. 2 will cancel with 2, kwa tunapata, sorry, tunapata V equals to P squared resistivity load times L squared over Vm times W. Ndio inakuwa formula katika DC 2 wire system with midpoint. Yeah. Okay. Tuende katika DC 3 wire system namba 3. 3 wire DC system. Okay, 3 wire DC system ambayo ni just a modification of 2 wire with midpoint SD. Okay, ni 2 DC generators. Okay, this is one outer, this is the mid wire, this is another outer, and the mid wire is being F. Because the potential difference between any of the outer of the and the mid wire which is connected to ground is V, and also here is V. Okay, if the load is connected between the two outers, the voltage between the two outers will be twice Vm. Okay, okay. Katika 3-wire DC system, loads can be connected between one outer and the mid wire or between the two outers. Inategemea na voltage requirement of your load. Okay, kwa hiyo for this analysis we shall consider that the load will be connected between the two outers. Okay, hata kama tukizingatia kwamba our load is connected between outer wire and the mid wire, tutapata the same results kama ambavyo tutaongoja tuangalie kwamba to consider the load is connected between between outer and between the two outers. Okay, kwa hiyo kwa tunasema kwamba current that flow I is given by power divided by twice Vm. Okay, kwa hiyo power loss is given by I squared R. Vile ni two outer wires, two conductors ambao liko responsible kubeba load current. This mid wire inabeba load current, unbalanced load current. Na for this analysis we shall assume that our load connected will be balanced. Kwa hiyo the current that will be flowing through the mid wire is assumed to be 0. Kwa hiyo load is balanced. Kwa maana hiyo tutakuwa hatu experience any power loss through the mid wire. Okay? Nadhani hii imenielewa. Kwa hiyo power loss itatokea tu katika the two outer wires. Kwa hiyo power loss will be twice times the will be. Kwa hiyo tukisubstitute for I, okay, tutapata power loss is given by twice times P over twice Vm squared times resistivity rho times L over L. Okay, kwa W itakuwa sawa kusema P squared resistivity rho times area over 2 itacancel na 2 moja hapo, kwa hiyo tunapata 2 Vm times area. Okay, kwa hiyo tunapata make A the subject. The subject tunapata A is given by P squared resistivity rho times length over twice Vm times W. Okay, lakini tunajua kwamba volume V is given by cross section area times length. Since ni two outer wires, okay, multiply by 2. Sawa. Sasa kwa vile tulisema kwamba the mid wire, this one mid wire, okay, inakuwa responsible for carrying unbalanced load current. In case load is unbalanced, no, that unbalanced current ina pass through that mid wire, ina flow through that mid wire. Kwa hiyo we don't need to have mid wire whose cross section area is the same as that of outer wire. Kwa hiyo huwa generally huwa tunaweka kwamba cross section area of mid wire inakuwa half of the outer wires. Okay, kwa hiyo the total volume sasa, the total volume of conductor material itakuwa ni 2 times area times cross section area, ambazo hizi ni for outers, for two outers, ndio, plus the volume of conductor for mid wire, ambayo tunasema ni half, kwa ni 0.5 times AL. Okay, na take kama half of the sawa. Kwa hiyo plus hapa tunapata volume of conductor material, sasa kusema 2.5 AL. Kwa tukisubstitute for A tunapata 2.5 times A is P squared times resistivity rho times length over twice Vm times W bracket times L. Okay, kwa hiyo hii itakuwa sasa nikisema 2.5 P squared resistivity rho times L squared over twice Vm times W. Okay, so volume of conductor material for 3-wire DC system. Okay, kwa hiyo tukitaka tufanye comparison, let's say